Hey everybody, this is the video to accompany the solutions to the 17B practice exam number 1 for the Dells class. Let's get started. Make sure I see it's good here. Okay, so first one says express the integral from 1 to 5 of x squared plus 3 over squared of x plus 1 dx as a limit of Riemann sums. Use the right endpoints of the subintervals. Be sure to first find delta x and x sub I. Okay, so delta x is going to be your b minus a over n, which is 5 minus 1 over n, which is 4 over n. Your x sub I is a plus I times delta x, which in this case is 1 plus I times 4 over n, or as I would prefer to write, 1 plus 4i over n. And then the way you write the integral is it's going to be the limit as n goes to infinity of the sum from I equals 1 to n of f of x sub I times delta x. So we're going to take our x sub I, which is 1 plus 4i over n, and we're going to sub it in for every x in our integral here. So this is going to be the limit as n goes to infinity of the sum from I equals 1 to n of 1 plus 4i over n squared plus 3 all over the square root of 1 plus 4i over n plus 1 times delta x, which is going to be our 4 over n. That's it. That's the whole problem. We don't want to simplify it. We don't want to try to evaluate it. We're just going to say that's the answer. Cool. Part 2, or question 2. Find y equal to f of x if f double prime is equal to 20x cubed minus 24x squared plus 16, given that f of 0 is 4 and f of 1 is 1. So to find f of x, we're going to find first f prime of x by antidifferentiating. So f prime of x is going to be the antiderivative of f double prime of x. So it's going to be 20x to the 4th divided by 4 minus 24x cubed divided by 3 plus 16x plus c. And since we're going to antidifferentiate this again, I would go ahead and simplify it. So f prime of x is 5x to the 4th minus 8x cubed plus 16x plus c. We don't know f prime of anything right now, so we can't plug in anything and find what c is equal to. So then we're going to antidifferentiate again to get the original function f of x. So we're going to get 5x to the 5th over 5 minus 8x to the 4th over 4 plus 16x squared over 2 plus c times x plus another constant. Let's call it d. Let's simplify. So f of x is equal to x to the 5th minus 2x to the 4th plus 8x squared plus cx plus d. If you plug in 0, f of 0 is going to be 0 minus 0 plus 0 plus 0 plus d. But f of 0 we were told was equal to 4. So d equals 4. And f of 1 is equal to 1 to the 5th minus 2 times 1 to the 4th plus 8 times 1 squared plus c times 1 plus d, which is 4, and that should equal, well, f of 1 is equal to 1. So then we're going to say that 1 minus 2 is negative 1, plus 8 is 7, plus 4 is 11, so 11 plus c is equal to 1, or c is equal to 1 minus 11, which is negative 10. Now we do need to write the final answer, so our y, or our f of x, is equal to x to the 5th minus 2x to the 4th plus 8x squared plus cx, so negative 10. I probably should have written minus 10, but whatever. X plus d, and that's our final answer. I do recommend when you're doing problems like this to circle or box your answers. It's usually a good practice. Let me move the keyboard out of the way here. It's a little bit in the way. Okay. Next problem. Problem 3. Find the general indefinite integral of e to the 3x plus 4 to the x minus 4x to the 5th plus 6 over x squared plus 1 minus the cube root of x. I would maybe do a tiny bit of rewriting, and I feel like this looks just a little bit blurry. Nope, I guess not. Okay. Maybe I can zoom in a tiny bit here. Sure, make it a little bit easier to see what's going on. Okay. So general indefinite integral, aka the antiderivative. The only thing I would actually probably really do is rewrite this. I don't think you really need to rewrite this as the integral of e to the 3x plus 4 to the x minus 4x to the fifth plus 6 times 1 over x squared plus 1 if you like. But really, the thing I was going to say is minus x to the 1/3 dx. So now if we integrate this, the integral of e to the 3x is e to the 3x divided by 3, because the derivative using the chain rule would make you multiply by 3. 4 to the x is a little bit harder, so I'll point out that when you take the derivative of 4 to the x, I'm going to say this off to the side here, the derivative of 4 to the x is 4 to the x times the natural log of 4. It's not quite a chain rule thing, although it kind of is, but I'll point out that the derivative makes you multiply by a constant, natural log of 4, so the antiderivative is going to make you divide by that same constant. So the antiderivative of 4 to the x is actually equal to 4 to the x divided by the natural log of 4. The antiderivative of 4x to the fifth is 4x to the sixth divided by 6. This 6 here hangs out, and the antiderivative of the 1 over x squared plus 1 is the arctangent of x, or if you prefer, the inverse tangent of x. Finally, the antiderivative of x to the 1/3 is x to the 1/3 plus 1 divided by 1/3 plus 1, which is 4/3 plus c. If I was going to simplify this, although I would probably just leave it like this, if you really wanted to, you could write it as, you could either write this as e to the 3x over 3 or 1/3 times e to the 3x. And you can write this as 1 over natural log of 4 times 4 to the x. And this is 2/3, or reducing that fraction, times x to the sixth plus 6 arctangent of x minus 3/4 times x to the 4/3 plus c. This would also be an acceptable, maybe even preferable, but either one of these should be fine. All right. Next problem tells us the u substitution to use. So they're telling us to let u equal that. Great. So let's find du. Du is going to be 20x to the fourth minus 40x squared, sorry, x cubed dx. I don't quite have that, but I notice here that 20x to the fourth minus 40x cubed, that is a cube, sorry, is exactly 20 multiplied. Oh, you know what? I made a mistake. I'm gonna have to fix that. So I should have said use the, so this should have actually been a plus sign. Sorry about that. I will fix that and let you all know. So I'm gonna let u equal 4x to the fifth plus 10x to the fourth, and that should be a plus there. So then if I, sorry, if I divide this whole thing by 20, or divide both sides by 20, I can say 1/20th times du is equal to x to the fourth plus 2x cubed times dx. And then I can replace my x to the fourth plus 2x cubed dx with 1/20th du. So I'm going to rewrite my integral as 1 over 4x to the fifth plus 10x to the fourth. Again, sorry for that error. Multiplied by x to the fourth plus 2x cubed dx. And then I'll point out, using a different color here, that this part here is equal to my 1/20th times du. And this part here is going to be my 1 over u. So that bottom part's u. This is going to be equal to the integral of 1 over u times 1 over 20 times du. I like to pull the 1/20th out in front, although it's not super necessary. But then integrating, we get 1 over 20, and the integral of 1 over u is the natural log of the absolute value of u. Then we need a plus c. We do need to plug back in what u is equal to. So that's going to be 1/20th times the natural log of the absolute value of 4x to the fifth plus 10x to the fourth plus c. Hopefully none of you have done the practice exam yet, and I can correct this for you all before you attempt it. But yeah, that should be a 4x to the fifth plus 10x to the fourth, and it should be a 4x to the fifth plus 10x to the fourth in the bottom there. Sorry about that. All right, so here's another problem. Find the integral of x squared times natural log of x cubed plus 2. They didn't tell us what to do here. It could be an erased by parts, it could be a u sub. If you're not sure, I would always recommend trying a u sub first. So it looks like a good candidate for u would be x cubed plus 2, because our derivative is equal to 3x squared, so our du is equal to 3x squared times dx. I don't have a 3, so I'm going to divide both sides by 3 or multiply both sides by 1/3 to get 1/3 times du equal to x squared times dx. You don't have to do it this way. Like some people just like underline the parts. I really enjoy or prefer rewriting the integral so that like my x squared is next to my dx. And it's totally fine to change the order of multiplication. So I'm write this as the natural log of x cubed plus 2 multiplied by x squared times dx. And then, oh yeah, there's my 1/3 times du. There's my u. U, yeah, fine, u. Ugh. The reason I say fine is I know I'm going to have to enrich my parts next, so I'm kind of regretting my choice here. Um, so here's what I would do. If you can, so I'll point out that when I integrate this, I know I'm going to end up having the natural log of u, which does require integration by parts. So what I'm going to do is I'm going to change this just slightly. I'm going to change all my u's to w's. And I recommend making this change if you know you're going to have to do integration by parts after doing a u substitution. So instead of using u, I'm going to use w. Cool. So now my w is equal to x cubed plus 2, my dw is equal to 3x squared dx, and 1/3 dw is equal to x squared dx. So my x squared dx is 1/3 dw, and my x cubed plus 2 is my w. So I'm going to rewrite this as the integral of natural log of w times 1/3 dw. I'm going to write the 1/3 out in front because standard practice. Now, the integral of the natural log of x or u or w is an integration by parts problem. You let u equal the natural log of w, and you let dv equal the rest. This is why I chose w, so that I can still use u and dv for my integration by parts. So I'm going to say that this is my u, this is my dv. So u is equal to the natural log of w, du is 1 over w times dw, dv is dw, and the antiderivative of dv is v, the antiderivative of dw is w. So then, rewriting my integral, it's 1/3 times all of uv, w times natural log of w. I did v times u, same thing, minus the integral of v times du. So that's w times 1 over w dw. That's going to equal 1/3 times w times natural log of w minus, okay, w times 1 over w is just 1, and the integral of 1 dw is just w plus c. Now we have to plug back in what w is equal to. So we're going to get 1/3 times, so w is x cubed plus 2, so I have x cubed plus 2 multiplied by the natural log of x cubed plus 2 minus all of x cubed plus 2 plus c. There's no need to distribute the 1/3. There's no need to distribute the minus sign. There's no need to simplify this anymore. We're done. Okay, next question. Water flows from the bottom of a storage tank at a rate of R of t equal to 300 minus 60 gallons per minute, where t is between 0 and 60. 60 is probably actually too big, but no worries. Maybe not, I don't know. Find the amount of water that flows from the tank during the first 20 minutes. So essentially, we have the rate of change, and if we're trying to find how much water is flowing out, we're essentially multiplying that rate in gallons per minute times the amount of time. But since the rate changes as the time changes, you can't just multiply them together, you have to integrate. So we're going to do the integral, right? So should say the total amount of water is going to equal the integral over the time period. The first 20 minutes means we're starting at time equals 0 and ending at time equals 20 of our rate 300 minus 6t. So we're going to integrate. So we're going to get 300t minus 6t squared over 2 is 3t squared from, I hope this doesn't come out to be negative. I did make this problem up, so it could. I'm a little worried it's going to be negative. Sorry for the bad problem here. From 0 to 20. And if we do that, we get, oh no, I think we're fine. I think we're okay. I think, I'm worried. So we get 300 times 20, which is, well, 300 times 20 minus 3 times 20 squared minus 0 minus 0. Let's see, 300 times 20 is 6,000. And 3 times 400 is 1,200. Oh, we're totally fine. So that's going to be 4,800 gallons. The total amount of water that has flowed out in the first 20 minutes. And again, the idea here is essentially if you're graphing, like, say, in fact, we could totally graph this, right? 300 minus 6t looks something like this. And right, that's time, and that's gallons per minute. We're essentially saying, well, if you look at some little slice of time, sorry, you can't quite see that, like over the first minute, so from 0 to 1, we say, well, great, the rate of water flowing out, we can estimate that to be 300, essentially. So it's 300 gallons per minute times 1 minute. So in that first interval, approximately 300 gallons flowed out. And then in the next interval, it's going to be a little bit less. And so what we're really just doing is we're finding the area under this curve from 0 to 20, because we're doing time measured in minutes multiplied by gallons per minute to give us gallons. And if you actually find that area, you can totally do it the same way, right? If you plug in 20, 300 minus 6 times 20 is 300 minus 120, which is 180. So then you can find the area, oh, and then if you plug in 0, you get 300 right here. So you can find the area here, which is the area of this rectangle. So 20 base times 180 height, plus the area of this triangle, which is 20 base, but it's 1/2 times base times the height, which is 300 minus 180, which is 120. And if I've done things correctly, this should add to the same amount. Let's see. 2 times 18 is 36, so 20 times 180 is 3,600. And 1/2 of 20 times 120 is 10 times 120, which is 1,200, which is exactly 4,800. I'm not saying you should do it this way. I'm just pointing out that it really does make sense to think about finding the volume of water by integrating the rate at which the water is flowing. Okay. Next question. Evaluate this integral. Integral from 3 to 5 of x squared over x minus 2 squared. Technically, you could do this in one of two ways, but the point here is to do it using a u sub with a back sub. You could also technically do this by doing polynomial division first, but then I think you're going to get stuck with any partial fractions, so I would rather not do that. So we're going to let u equal x minus 2. Our du is dx. How nice. So I'm going to start rewriting this. My integral from 3 to 5 of x squared over x minus 2 squared dx. I first worry about the dx. Well, dx is du. That's nice. My denominator is x minus 2, which is u, so u squared. But my numerator, I need to replace that x. So I have to take this u, say, great, u plus 2 is equal to x. So my numerator is u plus 2 squared. And then I should also change my limits of integration. So if x is 3, well, u is 3 minus 2, so u is going to equal 1. And if x is 5, u is going to be 5 minus 2, which is 3. Make sure they're in the corresponding order. And so just for example, if u equal to 3 had given me x equal to 3, and if u equal to 5 had given me, sorry, if x equal to 3 had given me u equal to 3, and if x equal to 5 had given me u equal to 1, I would write it 3 to 1, even though it feels like it's out of order. These always have to correspond to the corresponding x values. Then we need to multiply at the top. So the top is going to be u squared plus 4u plus 4 all over u squared. And then we're going to divide each thing by u squared, which I guess is a form of polynomial division. It's just easy. So you get u squared over u squared plus 4u over u squared plus 4 over u squared. We're going to simplify so it's easier to deal with. Integral from 1 to 3 of 1 plus 4 over u plus 4 times u to the negative second. We integrate, we get u plus 4 times the natural log of the absolute value of u. Here we're gonna get 4 times u to the negative 1 divided by negative 1, so that's gonna be minus 4 times u to the negative 1, all from 1 to 3. I would rather think of this as 4 over u plugging in. So when I plug in, let's see what I get. I get 3 plus 4 times natural log of 3 minus 4 over 3 minus, when I plug in 1, I get 1 plus 4 natural log of 1. Natural log of 1 is 0 minus 4 over 1, which is 4. I probably wouldn't simplify it. I probably would, but like I wouldn't spend time simplifying it until I've done other stuff. But simplifying here, let's see. I get 3. So I'll point that 1 minus 4 is negative 3. I have a minus minus 3, so that's a plus 3. 3 plus 3 is 6. So I get 6 plus 4 natural log of 3 minus 4/3. I don't really want to get a common denominator to add the 6 and the negative 4/3. I'm just gonna leave it like that. But I'd probably be fine to leave it like this as well. All right. Oh, this is the problem I was trying to come up with in class the other day. I shouldn't have been. So I was trying to come up with a partial fractions problem that came out nice, and I almost got it. So let's do this one. So it says use partial fractions. So we're going to factor the denominator as x plus 1 times x plus 3. We're going to set this equal to a over x plus 1 plus b over x plus 3. We're going to multiply both sides by the common denominator. So we're going to multiply both sides by x plus 1 times x plus 3. On the left-hand side, we just get the numerator, right? Because we're distributing to there. On the right-hand side, a over x plus 1 times x plus 1 times x plus 3. The x plus 1s cancel, and you get a times x plus 3. Here, if you multiply b over x plus 3 times x plus 1 times x plus 3, the x plus 3s cancel, and you get b times x plus 1. We pick convenient values of x. We pick x equal to negative 1. We get negative 4 minus 5 equal to a times negative 1 plus 3. Yeah, I guess I just came up with terrible numbers. I thought I'd come up with nice numbers, but I guess I didn't. Plus b times 0, so we end up getting negative 9 divided by 2 is equal to a. Similarly, if we pick x equal to negative 3, we get negative 12 minus 5, which is negative 17. I think this is the same example I came up with in class. Equal to a times 0 plus b times negative 3 plus 1, which is negative 2. So then we're getting 17 over 2, or negative 17 over negative 2, equal to b. So then we're going to rewrite our integral of 4x minus 5 over x squared plus 4x plus 3 dx as the integral of a over x plus 1, so negative 9 halves over x plus 1, plus b, 17 over 2, over x plus 3. And then we're going to integrate. So we get negative 9 halves times the integral of 1 over x plus 1 is the natural log of the absolute value of x plus 1, plus we get 17 over 2 times the integral of 1 over x plus 3 is the natural log of the absolute value of x plus 3, plus c. Indefinite integral need a plus c. Definite integral, we don't need a plus c. All right, we're almost done. This question's a little tricky, or at least it looks like it's tricky. Find the equation of the line tangent to the graph of y equals f of x at x equals 0, where f of x equals to 5 plus the integral from 0 to x squared minus 2x e to the t squared dt. So we want to find the equation of a tangent line to a graph at a point. You need two things. You need the point, both the x and y coordinate, and we need the slope. So the point is going to be x comma y, or x comma f of x, but we're plugging in 0. So we're going to get 0 comma f of 0. F of 0, let's see, f of 0 is going to be 5 plus the integral from 0 to 0 squared minus 2 times 0 is 0 e to the t squared dt. But the integral from 0 to 0, since you don't have any width along the x-axis, that has to be 0. So f of 0 is just 5. So that's the point. It happens to also be the y-intercept, which is kind of nice. So then we're going to find the slope, which is the derivative, f prime of 0. So first we're going to find f prime of x. So we're going to take the derivative of this. So f prime of x is equal to the derivative of 5 which is 0, plus the derivative of the integral from 0 to x squared minus 2x of e to the t squared. The whole point of this question is make you use the first part of the fundamental theorem of calculus. The derivative of 5 is 0. The derivative of the integral of a function is that function with this plugged in, and then since it's more complicated than just x, we have to multiply by the derivative of this stuff. So it's going to be e to the x squared minus 2x squared, or plugging that in for t, multiplied by the derivative of x squared minus 2x, which ends up being e to the x squared minus 2x squared times 2x minus 2. But we want to find the derivative specifically when x is 0, so then f prime of 0, we're going to plug in 0 for x and get e to the 0 minus 0 squared is still 0 times 2 times 0 minus 2. So that's 1 times negative 2, which is negative 2. And that's our slope. So we have a slope, we have a point. So then our equation, you can either use y equals mx plus b and say y equals negative 2x plus 5, since we actually know the y-intercept is 5. But if you wanted to show more work, you could have said like y minus 5 equals your slope times x minus 0. And then, oh yeah, y minus 5 equals negative 2x, and then add 5 to both sides to get back to there. So there's the equation of our tangent line. Kind of weird question again. Really the point of this question, and again, in general, if you see like an integral with a funky x thing up here, you're almost always going to be using the first part of the fundamental theorem of calculus to take the derivative of that, and then you have to multiply by the derivative of x squared minus 2x in this particular case. Okay, a couple more here. Yeah, I didn't really mean to have two problems where we had a U sub and a whatever, but oh well, such is life. So make a U sub, although I would use T instead of U or W instead of U, and then use integration by parts to evaluate the integral. So the only real valid choice for a U sub here, or T sub, is the square root of x. So we're going to let T equal the square root of x, which is x to the 1/2, and then our dt is equal to 1/2 x to the negative 1/2, which is 1 over 2 root x dx. This doesn't really turn out so well, except we can bring the 2 root x over to the other side and say 2 root x times dt is equal to dx. But then t is equal to root x, so root x is equal to t. So this is really 2 t dt is equal to dx. Or an alternative way to get there is to say, hey, look, if t is equal to the square root of x, then t squared is equal to x. And if we take the derivative of that, it's 2t times dt, and it's equal to the derivative of that, which is 1 times dx. Oh, same thing. So then we're going to rewrite this integral as, so sine of root x is going to be sine of t, and then dx is going to be 2 times t times dt. And now it's an integration by parts problem. So we're going to let u equal this part and dv equal this part. So u is equal to 2t, du is equal to 2dt, dv is equal to sine of t, dt, and the antiderivative of sine of t is negative cosine of t. So v is equal to negative cosine of t. So then this is going to end up being equal to u times v. So I don't like to write 2t times negative cosine of t. I would write 2t times negative cosine of t. Doesn't matter if we put negative in front or not. But if you put it there, you have to put parentheses around it. It just kind of looks ugly. Minus the integral of v times du. So it's negative cosine of t times 2 dt. I would probably rewrite this just slightly. I would say, great, I've got negative 2t cosine of t. Minus and minus is plus, bring out the 2, integral of cosine of t dt. The integral of cosine is sine, so we end up getting negative 2t cosine of t plus 2 sine of t plus c, and then we plug in root x for each t and get negative 2 root x times cosine of root x plus 2 sine of root x plus c. Last question. Evaluate the following by first recognizing the sum, not sums, as a Riemann sum for a function defined on the interval from 0 to 1. So the idea here is that this is the limit of a Riemann sum, meaning it's an integral. So what I'm noticing here is this is like my delta x, and this is like my f of x sub 1. This is like my f of x sub 2. This is like my f of x sub 3, all the way to my f of x sub n. But the limit of a Riemann sum is equal to the integral from 0 to 1 of my f of x times dx. So I really just have to figure out what my f of x is here. Well, let's see here. So it looks like, so again, I'll point out my delta x is that, and my x sub I would be my a plus I times delta x, which would be 0 plus I times 1 over n, or I over n. So f of x sub 1 is really f of 1 over n. So essentially the 1 over n is my x. So this looks like x times the square root of 1 plus, this isn't x, this is x squared. So it looks like my f of x is x times the square root of 1 plus x squared. Which seems to play out, right? If x sub 1 is 1 over n, that's a 1 over n times the square root of 1 plus 1 over n quantity squared. And if x sub 2 is equal to 2 over n, that's a x times the square root of 1 plus, that's a 2 over n squared. So yeah, it looks like it's x times the square root of 1 plus x squared. And now we can integrate that. We're going to do a u sub. So our u is equal to 1 plus x squared. Our du is 2x dx. 1/2 du is equal to x dx. There's my x dx, which is equal to 1/2 du. So we're going to rewrite this as the integral of 1/2 du. And then this square root of 1 plus x squared is going to be the square root of u. My new limits of integration, well, if x is 0, u is going to be 1 plus 0, which is 1. If x is 1, u is going to equal 1 plus 1 squared, which is 1 plus 1, which is 2. C is mu. So then that's going to be 1/2 the, let's do it this way. 1/2 the integral from 1 to 2 of u to the 1/2. And then we can integrate it and get 1/2 times u to the 3/2 divided by 3/2 is multiplied by 2/3 from 1 to 2. Since we're already in terms of u, we're not going to change back. So 1/2 times 2/3 is 1/3. And then we're going to get 2 to the 3/2 power minus 1 to the 3/2 power, but 1 to any power is 1. And that is our final good answer. Kind of a tricky problem. All right, that is all I got. I will point out, most of these problems did come from a previous actual exam or their variations of them. So this is the totally reasonable to expect to see on Monday. All right, best of luck to all of you.